Right, so in this video, we're going to look at question 5 and 6 of the exam. And we'll start from here, which is part of question 5 that remained. So we have this question. It says, sketch the graph of the function f of x equal to 1 minus 2 cos x for the interval. So 0 up to, that's 2 pi. This has been given in radians. In degrees, that is 0 less than or equal to x less than or equal to 360 degrees. So we must sketch that function. In order to sketch this function, so we have the function f of x is equal to 1 minus 2 cos x. So now we are graphing the function of cos x. So in general, cos x, the function of cos x looks something like this. It starts from the top there, use white, starts from the top here. So if we have an amplitude of 1 to -1, like that. So it starts from here, the top, then it will go, pass through the middle, then go down there, which is at a point here. So to go down there, and then pass again through the middle there, and then go to the last point, which is going to be up like that. So for one period, this is how the graph of sine, of cosine, looks. So this is for one period. And one period, we know is just 360 degrees, or what? 2 pi. That's 2 pi, that's 3 over 2 pi, which is 270 degrees. Then here we have pi, which is just 180 degrees, and pi over 2, that's 90 degrees. Then here, the start point, 0. So this graph can continue for as many periods as it can. Even the other way, it can go like that, all the way like that. So this is the general form of the cosine graph. Now, if we have, so in the case where we have, okay, so now that is when this is what is positive. Now, if we have cosine equal to negative like that, it's going to be inverted, meaning it's going to start from the bottom and not from the top. So we have it like this. So instead of it starting up here, it's going to start from down. So it go down, the middle, up there, then there, and then to conclude down there. So it's going to look something like this. Okay. All the way like that. So this is one period of the cosine graph when negative cosine graph when it has a negative value there. Okay, now one thing to note in our question, we have this value here. Okay, let's just go straight into graphing this one. So how we graph this question, now after having that bit of a background to what we're going to do. So when we have this question like this, we can write this as negative cos x then plus 1. So the value that is in front, this value that is always in front here is called the amplitude. And the amplitude is always what? Positive. So meaning the amplitude, we say the amplitude is always what? Positive. So we get -2. The modulus of -2 is what? 2. So this is our amplitude. So our amplitude is how high the graph is going from the baseline. So now, if we have something like this is our starting point, as we said, is okay, we have 0 there. So how high to be going? So 1, we're going 1, that in our first example. But now, in this case where the amplitude is 2, meaning it has to be attaining 2 there. And same even down, that has to be like that. So meaning when it goes from here, from there, going down like that up to 2, then like that, then going like that. So this is how it's going to be. So if you had number 3 here, meaning it's 3 units up, so meaning you start from what? From 3 like that. If it's what? Just like that, that's the amplitude. So now, raise this. Apart from the amplitude, one other thing you must take note of is this value here. So that value there, 1 is the vertical shift. So this is the amplitude we're talking of. Then the 1 there is the vertical shift. So the vertical shift is where our graph is going to be starting from. So we were starting from 0 in this case. If you saw, we're just passing through this point 0. They were seated on this point, which is what? 0. So now it can take a shift either in the negative or in the positive direction. In this case, you see it's positive, so meaning it should be at positive 1. So positive 1 like that. That's where our baseline now will be. So at negative, at positive 1. So our vertical shift is just y equal to 1 that way. Then now, we already found our amplitude, which is 2. Meaning from this point, which we have, this point 1, when we add 2 going up, 2 units going up, so we have 2 here and 3. So meaning our amplitude is going to go up to 3. Then down, that's going to be at 0, and there at negative 1. So then we've already been given our period, like it has to be from 0 up to, this is our period here. So we'll use that. Now, from here, you know that it's going to, you know the general form of the graph. So if we were to say, okay, if we were to say we have those, it's going to pass, it has those 4 points on the line. So we have 1, 2, 3, and then 4, which we're saying this is 2 pi, which is 1 period, like that, 2 pi. Then here it's 3 over 2 pi. Then you have pi. Then you have pi over what? Over 2. So in short, this is 90 degrees, 180, 270, and 360 at the end there. So now it has to pass through what? Through these points. So now from here where we are, 1, then we know our graph of what? Of sine starts from up there. So to start from here up, 1, then it's going to pass through this point here. We're saying the middle point that is in relation to this, which is at pi 90 like that. Then it will go, then down our amplitude is up to negative 1. So it will go here, negative 1. Then it's going to pass the midpoint, which is just here like that. Then it's going to go up to that. So let me just erase here. So, okay, so it's going to go up there where there's 2 pi, like that there, which is the ending point. So you connect these dots. Now, there's this negative here. So if this was just 2 cos x plus 1, then it will look this way, which we're going to graph. So I'll graph it such that you see it will pass there like that, cos, then it's going to go the way. Okay, so the first part, let me write it properly. There, it's going to go. Okay, so this is how my graph is going to look. So I'll have something like that. If it was just a positive like this. Now, in our case, it is what? It is negative. So for the fact it is negative, meaning it's going to be inverted. It's going to be inverted. So now let me erase here such that we graph the one with a negative 1. So this is going to be, okay, so write my lines I have here. Okay, and like that. So this is going to be, we said our vertical shift is what is 1, meaning this point 1, it's where we're saying our baseline is going to be. Of course, you can write here to say you have pi over 2, because this is 0, pi over 2. You have here as pi, then you have 3 over 2 pi, and then you have 2 pi. So, because they've said at that interval there, which is this here, then we had an amplitude of 2. So our amplitude is equal to 2. So we said this value in front, the modulus of this value, which is just going to be 2. So meaning from 1, we have 2, then 3 there. It's going to go up to 3. Then down there, 0, then negative 1 there. So now, from here, we graph, meaning it's going to start, because of the negative, it will start from the bottom, meaning from here, it will pass through the middle, which is going to be there. Then it will go up to here. Then it's going to pass through that point. Then, okay. Then down here, it's going to go, okay, so down, just a moment. So down there, it's going to go where negative what is. So you can connect these points, and it's going to go like that. Okay, so like that, then like that. So this is how your graph is going to look. So this is the graph this is the graph f of x equal to 1 minus 2 cos x. Do I have any questions? This is how you graph this graph. Any question? All right, guess that's clear. Let's move on to the next question. So our next question is this one, and it's easy. It says find the domain of the function where we have this here. So in order to find the domain of this one, what we do is, so we must find the domain of f of g of x, and we must find the domain of g of x, which is the function you're putting into f of x. Find the domain of this one, then you put these together. That will be the domain of the entire thing. So let's work out that. So f of g of x is just the same as writing this. Okay, like that. So in the function f of x, this one, where there's x, I must replace this function g of x. So all right, x plus 2, then where there's x, I replace that function g of x, which is just 3 minus x, like that. Then I have plus 2. So this is what I get. Then I have g of x, that g of x is just 3 minus x. So I should get the domain of this one. So what will be the domain of this one? So you always want to make sure that in here, what you're having, you're going to be having what? Positive values. So that has to be 3. You must only plug in values that are greater than or equal to what? 0. So the value should be greater than or equal to 0. Then you have negative x greater than or equal to, then that is 3. Then when you divide, this n becomes x less than or equal to 3. So x less than or equal to 3. So when you put any value greater than what 3, this will not be defined. So this is the domain of this function. Then when you check out the other one here, when you check out the other one, you have to check this same part again, of which the same part is the same which we've already found that x is less than or equal to 3, like that. So you can plug in anything less than x. So meaning the domain, in this case, the domain of this f of g of x is just the same as the domain of g of x. So even when we unite them, it's just going to give us the same one, which is just x must be less than g of x. Or you can write it in an interval like this, from negative infinity all the way up to 3. So this is going to be your domain. Okay. Now, next question. Next question says if xy plus y squared is equal to 1, find dy dx. So here we use implicity differentiation. We have xy plus y squared is equal to 1. So we must find dy dx. So in this first part, we have x and y. So, and we see that x is just multiplying with what? With y. These are just multiplying. So meaning when differentiating this, I must use the product what? Rule. And the product rule, here what I do when using the product rule, I must differentiate the first part. So if we have two functions, let's say we have u and what? U and v, and they're both differentiable, meaning can differentiate the first part and keep the first part the same, second part the same. Then you add, then you differentiate the second part and keep the first part the same, like this. So this is your product rule. So let's do that. So when we differentiate x, x just gives us what? 1. Then you keep the second part the same, which is y, like that. Then plus, so you keep x the same, then differentiate y. So when you differentiate y, you have 1, but we're differentiating in respect to what? To x. So there, that will have dy dx, like that, because this y is not x. Then the following part, you have to differentiate again. So now here we just use the power rule. So we say the 2 will drop, then you have y. So y minus the power there, minus 1, you just have 1. You remain like this. So remember it's respect to x. So you put your dy dx like that. Then you differentiate a constant on this other end, you just get 0. So here, meaning we'll have y. If you write this like this, y x dy dx plus 2y dy dx is equal to 0. Then here I can move my what? This y. This y can move the other side, which the additive inverse of that is going to be negative y. So meaning I'll have, and at the same time, I can factor out dy dx from these variables. So I have dy dx, and when I factor out, I remain with x there plus 2y is equal to negative y. Then I can divide x plus 2y on both sides, and I just remain with dy over dx equal to negative y over x plus 2y. So this is what I get when this is how I find my dy dx. So this is what we do for question involving implicit differentiation. Okay, so our next question is this one. It says, use integration by parts to evaluate the following integral. So to integrate this, you must know, use this word here, leate, which shows you which part you're going to make to be your what? Your u. So you have the first part, which is stands for, so this L stands for logarithmic. Then you have this one for inverse trig function. Then you have A for algebraic. Then you have T for trigonometric. Then you have E for exponential. So you must, which one comes first between amongst these ones? So when you check out, so X is an algebraic function, then E here, this is an exponential function. So now we see that A comes before E, so meaning you let what? You let X there to be your U. So you say let U equal to X. Then whatever has remained, the E dx here is going to be your dV. So you say dV should be equal to E to the power X, then dx like this. So here I will differentiate. So I'll get du is going to be equal to, and I differentiate x, just get 1 and that remain with dx. So this is going to be like this. Then I integrate on this other side. So when I integrate this side like this, I'm going to get that this side I'll get v is equal to, then here, so when you integrate the exponent like this, e is just going to be the same like that, divided by, so you differentiate what you have there in the exponent. So we have negative x like that. So when I differentiate negative x, I just get negative 1. Then you divide this, and this will just give you negative e to the x like that. So this is what you get. So I have my v, I have my dv, and I also have my du and my u. And I know by parts, this is going to be equal to, it's going to be the integral. So integral of e of x, e like that, dx is just going to be to u v minus v du like this. So I just replace now, my u is x. So I replace x there, and my v is here what I found, negative e raised to the negative x like that. Then minus the integral, my v, again, that's negative e to the negative x. Then du, as you can see, du is just equal to dx. So I'll bring here dx. So from this stage, the next thing you do, okay, let me erase this part. Next thing now you do, you just say, so here we can multiply x and this one, then we get negative x e to the negative x. Here, as you can see, this negative and this one, this negative multiplies, it becomes positive like that. Integral of e to the negative x dx. Then here, you just say negative x e to the x. I can integrate this part here. So when I integrate from just like we did before, we'll just get negative a e to the negative x like that. Then plus our constant c. And from here, you can factor out a common factor, as you can see, e to the x, negative e to the x. So negative e to the raised to the negative x like that. There you remain with x in the first one, then that part you remain with 1, then plus c. Then you're done with this part. So that's how you integrate this question by parts. Just find your u, your v, and your du like that, and replace in this formula by the same steps which we did, by first identifying which one to make your u and which one to make your dv. So this is what you do. Okay, the next question. We have this question here. It says if sine alpha is equal to 3/5 and sine beta is 5/13, where alpha and beta are acute angles, find the values of alpha plus beta. Okay, so what you do in this one, you say, so you've been given sine alpha equal to 3/5. So you write a triangle, you draw your right angle triangle like that. Then say our angle here is alpha, And we know that sine is just opposite of our adjacent. So that's your O and that's your H. So meaning from this angle here, our opposite is here. So 3 will be there, and our hypotenuse is there, 5. So to find this adjacent side, of course, you just say 5 squared, the hypotenuse squared minus 3 squared, like this. Then it will give you this side. We can name this side x equal to x squared. So this is what you're going to get, and that will be 25 minus 16 is equal to x squared, and that is going to be, okay, that's supposed to be 9 here. 3 squared is 9, and this is going to be x squared is equal to 16, and introducing the root there, you're going to get x is equal to 4. So you get x equal to 4. When you introduce the root here and there, okay, you have x equal to 4. So meaning the adjacent side there is what? Is 4. Then you do the same for the other one. Sine beta is equal to 5 over 13. Then you draw your triangle like that, and you have, so you have this here to be your beta, and that's, so this is your adjacent. So we don't have the adjacent, which is y. Our hypotenuse, as you can see there in the bottom, which is h, we have 13, and our opposite is 5. So this other side we have 5. So we do the same, 13 squared minus 5 squared. Of course, this is by Pythagoras' theorem. X squared, here that is 169 minus 25 is equal to y squared, and this is 144 is equal to y squared. Introducing the square root there, and the other side, I get that y is equal to 12. So that there, my y is equal to 12. Now, after finding these values, okay, let me erase here. Okay, erase this and erase that. So I have that this here, my adjacent is 4, and the other adjacent there is 12. So the way we are going to find this question, so we see that we are adding here these are two angles, which is alpha and what, and beta. So when you're adding in this case, so they're telling us to find the value of sec alpha plus beta. So now the way we will find this one, we know that the inverse of this is just 1 cos alpha plus beta. So we can easily find this here in the bottom. So if we can find this, then we just say whatever value we find over 1, then that will be our sec alpha plus beta. So to find that, we use the formula cos. So alpha plus beta must be equal to cos theta cos beta minus, that's minus sine alpha sine beta. So let's replace that in the equation that we have. So we have cos theta. So we can find cos alpha, cos alpha here. Cos is just adjacent over the hypotenuse. So our adjacent is 4, our hypotenuse is 5. So cos alpha is just 4 over 5. Then cos beta here, do the same, adjacent 12 over hypotenuse is 18. So cos beta is going to be 12 over 13. Then we have sine alpha and we have sine beta, and we can replace those. So we have cos alpha plus beta is going to be equal to, our cos alpha is 4 over 5. Then our cos beta is 12 over 13. Then minus sine alpha is 3 over 5. Then you have sine beta to be 5 over 13. Okay, then you can solve this here. So when we multiply these two here at the first part, we get 48 over 65, then minus this other side, we get 3 over 13. Then working this out to be a single fraction, we make this a single fraction, we'll get cos alpha plus beta to just be equal to 33 over 65. So that's what we'll get. And so meaning for us to find sec alpha plus beta, we just say 1 over cos alpha plus beta. So which that is 1 over 33 over 65. So this just inverts the numbers, so just exchange, and you get this is going to be equal to 65 over 3. So sec alpha plus beta is equal to 65 over 33. So this is your answer for this question. Okay, so the next one is here. We are told to prove the identity. So we must prove that this part is equal to the other one. So we start with the left-hand side, and we show that the left-hand side is equal to the right-hand side. So you have tan x plus quarter x. So we can write this as sine x over cos x, because I know sine cos divided by sine, I get tan x. Then the other side, I can write cos x over sine x. Okay, from this point, when I divide this, I get cot x. So at this point, making it into a single fraction, the common factors going to be sine x cos x. They're multiplying sine x cos x. So when I divide this cos into this one, I remain with a sine here down. So sine is multiplying with sine x there. So that would be sine x squared. Plus, I divide sine here, I remain with cos. Cos multiplying with that cos there, I get cos x squared. Like that. So this here, I know the identity, sine x plus cos x, I'll just get 1. So I'll get 1 over sine x cos x. So now, here I see that the left-hand side is equal to the right-hand side. So hence shown. So I have proved that identity. Okay, this is how you do this one. The next one, which is the final question, is this one. So here we're being told to solve the equation. So we solve 3 minus 3 cos ax is equal to 2 sine squared x. So for the interval we've been given, that's 0 degrees equal greater than, less than, or equal to x less than or equal to 360 degrees. So this is what we have. So now I have cos and sine squared this side. So I can write this in terms of just cos in terms of cosine. So now, how can I write that? I can replace this here, sine squared, because I know that if sine squared x plus cos squared x is equal to 1, so here it means when I make this a subject, I'll have cos squared x, sine moves the other way. Okay, when I make sine, I mean, let me make sine the subject, sine squared x the subject, meaning the cos moves the other way around, then I have sine squared x equal to 1 minus cos squared x. So I can make that replacement in my equation, then I have 3 minus 3 cos x is equal to 2 1 minus cos squared x, like this. Then I can distribute the 2 there. I have this cos x here is equal to 2 minus 2 cos squared x. Okay, Now I can move everything to the left side. I'll have 3. When this goes this way, it becomes -2. Then I have -3 cos x. Then I'll have +2 cos squared x, like this. Then from here, when I subtract 3 minus 2, I get 1, and I have 3 cos x. Then I have plus 2 cos squared x. At this point, I can say I'll let cos x equal to, so cos x equal to t, such that I am able to solve this as a quadratic equation. So this is equal to 0, this side equal to 0. Okay, not this part here. Yeah, here equal to 0. So then when I let that to be equal to that, I'll have 1 minus 3. So where there's cos x, I replace t. Then plus 2, where there's cos x, I replace t, and I have t squared equal to 0. So I can solve that equation. Erase this top part. So I can solve that equation. Okay, so solve this equation. I'm going to say, okay, so we have 1 minus 3t plus 2t squared is equal to 0. So I can find my product here. Product to just be, so 2 multiplied by 1, I get 2. Then my sum is -3. So my factors are just going to be -1 and -2. So when I multiply this, I'll get +2. When I add, I get -3. Can replace there. So I have 1 minus t, then minus 2t plus 2t squared is equal to 0. Then I'll can factor out this and this other side. So here, I know that factor is just 1, and I have the same thing inside. Then here I can factor out the what? A -2t. Then that I'll remain with 1 there, and it divides, and I'll remain with -t there. This is equal to 0. Then I can now group 1 minus this one, minus 2t, like this. And I just pick one of these. That's 1 minus t is equal to 0. So here I'll get 1 minus 2t is equal to 0, and 1 minus t is equal to 0. Then this is going to be 2t, -2t is equal to -1. And this here I'll just get t is equal to half. Then the other side, I'll just get t is equal to 1. Okay, so these are my values of t. So with the values of t equal to 1 and half, I can use that from the equation which I had come up with at first. So we had the equation that cos x must be equal to what? T. So here, which means cos x is equal to 1, and cos x is equal to half. So this is what I get. Cos x equal to that, and cos x equal to half. So those are my two values. So what do I do with those? So I check now in this interval I've been given. So from 0 to x. Okay. So if you have your quadrants like that here, so you have a circle like that. It's 360 degrees. So in the first part here, you know that this will end up to 90 degrees, from 0 to 90 degrees. Then from 90 to 180, and from 180 to 270, and up to 360. So these now I will check. So I'll check where is cos equal to what? To 1. Where is cos x equal to 1? So where cos x is equal to 1. So cos x is equal to 1 when x is what? When x is 0. So when x is 0, cosine is equal to 1. So when x is 0 degrees, cosine is equal to 1. And then when x is equal to 360 degrees, then cosine is equal to 1. So I check also when is x equal to what? To half. So from your special angles where you know cos 60, cos 60 is going to give you half. So you know that x here is going to be 60. And also when x is equal to 300 degrees like that, then I'll have that this is going to be half. So when x is 360, cosine will be what? Will be half. So meaning those there are your values of what? Of which are valid for x in that interval. So x equal to 0, then so x equal to 0, x equal to 60 degrees, and then x equal to 300 degrees, and x equal to 360 degrees. So those are your values of x valid for that interval. So that's how you solve this question. Okay, so we have this last question here. Yeah, so this last question has, so we have to sketch the graph, but when as we are sketching, we also have to include or state the domain and the range and the horizontal asymptote. So we have y equal to, so that's negative 2 raised to the power x plus 3. So this is an exponential axis equation. So we must sketch this. To sketch this, first of all, you must know how to get this horizontal asymptote. So that horizontal asymptote is just the y value in this case. So, and it's gotten. So if you had y equal to, let's say, 2 like this. So in this case, the horizontal asymptote is just y equal to 0. So y equal to 0, that's your horizontal asymptote. So now when you have this shift, in this case where you have 3, so whatever shift you're going to get, that shift there is going to be what? Your horizontal asymptote. So that will be at y equal to 3. That's your horizontal asymptote. Okay, then from here now, you just get the values, which you get two values, which are going to use to what? To plot. So you have to have an x value, of course, and the y value. So you get one value. When you equate what you have in the exponent, in this case, we have x equal, we just have x there. So you have 2 to the power x. So you equate that to 0. So meaning your first value of x is going to be 0. And you get one value to the what? To the right of 0, which is 1. So in this case, to the right, we're going to get 1. Then from here, you have to get corresponding values. So you replace in your equation there. So y minus negative there. So when x is 0, that will be raised to the power 0 plus 3. And you get y equal to, that will give you 1. Anything raised to the power 0 is 1. And you get negative 1 plus 3. And that is going to be equal to 2. So when x is 0, y is 2. Then you replace again when it's 1. So you get negative 2 raised to the power 1 plus 3. And you get negative 2 plus 3. And y is going to be equal to 1. So when x is 1, y is also 1. So that's how you find those points there. So now, with what you have, you can now sketch your graph. So to sketch this graph, let's draw our x, y plane like that. Okay, so from here now, you must first indicate your what? Indicate your asymptote. So your asymptote is y equal to 3. So y equal to 3, meaning this point here, y equal to 3, it's not what? We have no value corresponding to this one. So it's like that. Then you plot the other one, which you got when x is 0, you get that your y is what is 2. So it's that point there. So we say that is 2. Then when x is 1, let's say 1 is there, just down below there, then you get that this one also have a corresponding value of 1. So let's say y1, x1 is there, and y1 is there. So to be like this. Then these are your values which will help you plot. Then now you always start from the asymptote. So you start from the asymptote there. Okay. Then you come and then pass through the points like that. Then to continue to go like what? Like that. So this is how your graph is. So it is inverted because of the negative sign in front of this part here. So when you multiply that, you get 2x raised to the power 3 like that. So meaning it has to go towards the negative what direction. But if this was positive, meaning you'd start from this part, then it will go positive. So it would be, let me write it in white, it would go like this. Yeah. Even these other points will be corresponding going to the positive side. But now that it's negative, it will go down like that. So this is how it will be. So now to find the domain, your domain, so your domain, this function can take up any x values. So from negative infinity to positive infinity, when I plug in any value here where x is, I'm going to have what? This is going to be valid. Everything here is going to be what? To be valid. So I can plug in any value there. So my domain is just from negative infinity to positive infinity. Then my range now, your range you always start. So in this case, we see that this graph is going all the way up to like negative infinity there. That's where it's starting from, negative infinity. And it's going all the way up to 3. And 3 there is not included because we have a dotted line there. So it's going from negative infinity. So negative infinity there. So range is in terms of the y. So negative infinity up to 3 there. So it's ending at 3. So, and 3 is what? Is not included. So it will be open at 3. So this is your domain, your range, and of course your asymptote you've shown. You can write that my horizontal asymptote is just y equal to 3. So this is how you graph this exponential function. And this marks the end of this class. I don't know if there are any questions.